Hello students and good morning. So today I am doing class 12 science. The topic is the new topic, that is matrix. So today I'll start the introduction part of matrix. So before I discuss about this matrix, let us take an example. Ram has 5 oranges and 4 apples. Sita has 9 apples and 7 oranges, and Geeta has 2 apples and 6 oranges. So there is another way of representing these sentences, right? So this matrix can be written in the form, this is known as square bracket, or it may be within the first bracket. So I told you that there is another way of representing these sentences, right? So let us write, so this is the square bracket. This is known as the matrix notation also. So let us write here the name of the persons, right? That is, first person is Ram, second person is Sita, and the third person is Geeta, right? So these are the name of the persons, right? And here in the above part, we will write the name of the fruits, that is oranges and apples. So there are 2 types of fruits there, oranges and apples, right? So now Ram has 5 oranges. So Ram has 5 oranges. So we write how many oranges does Ram have? 5. So 5 oranges. How many apples does Ram have? 4 apples. So Ram has 4 apples. Next, Sita has 9 apples. Sita has 9 apples. And Sita has how many oranges? 7 oranges. And also Geeta has 2 apples. Geeta has 2 apples. And Geeta has how many oranges? 6 oranges. So there is another way of representing these sentences. So this is the quick way. That is, quick way means you can easily say that how many oranges does Ram have? 5 oranges. So you can tell that how many oranges does Ram has in the quick manner, or you can immediately say that how many oranges does Ram have. Now from this sentence, how many apples does Geeta have? So you have to see the first sentences, you have to see the second sentences, and you have to see the third sentences and say that Geeta has 2 apples. But from this representation, you can immediately say that how many oranges does Geeta have? Geeta has 6 oranges. Geeta has 2 apples. Sita has 9 apples, like that. So from this representation, we can easily say that how many apples does Geeta have, how many oranges does Geeta have, etc. Okay. So this representation is known as matrix. Is that clear? So you can write these oranges and apples here and Ram, Sita, Geeta here. So this is known as the column part. This is known as the row part. This horizontal is known as row and this vertical is known as the columns, right? Or you may write here, you can write it within first bracket also. So this matrix representation is either this square bracket or third bracket, or you may have first bracket also. We can write here first bracket also, right? So now you can write here the name of the persons, Ram, then Sita, then it is Geeta, right? And here you can write the name of the fruits, that is oranges, and this is apples, right? So how many oranges does Ram have? 5 oranges. So how many oranges does Sita have? 7 oranges, and Geeta has 6 oranges, right? How many apples does Ram have? How many apples does Ram have? 4 apples. How many apples does Sita have? 9 apples. And how many apples does Sita have? Does Gita have? It is 2 apples, right? So we can write down Rita, Sita, Ram. We can write Ram, Sita, Gita in the horizontal position, and you can have name of the fruits in the vertical direction. Okay. So this is another way of representing these sentences. So this is the quick way of representing these sentences. That is, looking at this matrix notation, you can easily say that how many apples does Gita have? Gita has 2 apples, like that. Okay. So this is the matrix. So what do you mean by matrix? Matrix is an array or arrangement. Array means arrangement. So how can we define matrix? Matrix is an array in which the elements or members are arranged in some rows and in some columns, right? So this is your matrix. So in this case, these 5, 4, 7, 9, 6, 2 are known as the elements or members of the matrix. Here also these 5, 7, 6, 4, 9, 2 are known as the elements or members of the given matrix. Okay. So let us write down matrix in a general way. Okay. So suppose the given matrix is A. A is equal to, let us write it within square bracket. Okay. So this is A11, A12, A13, dot dot dot, A1n, right? So this is A21, A22, A23, right? Dot dot dot, A2n. Clear? Then this is A31, A32, A33, dot dot dot, A3n. Okay? Then there are other elements also. Right? Now here you write AM1, AM2, AM3, dot dot dot. This is AMN. So all these A11, A12, A13, etc. are known as the elements of the matrix A. Okay? So now A11, like A11, this first number represents row and this second number represents column. It represents column, right? That means A11 means this is the element in the first row and in the first column. That is A11. This is the element in the first row and first column. What is A33? This is the element in the third row and third column. That is A33. What is AMN? This is the element in the mth row and nth column. So how many elements are there altogether? There are m cross n elements. So how many rows are there? 1, 2, 3, 4, 5, etc. dot 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 m. There are m rows. So how many columns are there? First 1, 2, 3, dot 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 n. So how many columns are there? N columns. So this first row, first will indicate, this m will indicate row and this n will indicate column. That is, there are n rows and n columns. Is that clear? So how can we define a matrix? A matrix is an array in which m into n elements are arranged in m rows and n columns. So we can define the matrix in this way. So we can write down the definition also. So definition is so what is the definition of matrix? A matrix is an array means arrangement in which m cross n elements are arranged in m rows and n columns. So a matrix is an array in which m cross n elements are arranged in m rows and n columns. So is that clear to all of you? So this is the definition of matrix. Okay. Now the plural form of matrix is matrices. The plural form of matrix is known as matrices, right? This is the plural form of matrix. Okay. So now let us discuss about the types of matrix. So types of matrix or matrices, right? So number one, rectangular matrix. Number one is rectangular matrix. So what type of matrix is known as rectangular matrix now? I am giving you an example of rectangular matrix. Like if you have in the first row there are 3 elements 2, 3, 4, and in the second row there are 3 elements, that is 5, 6, 7. Okay. So how many rows and how many columns are there? There are 2 rows and how many columns? 3 columns. This is known as the first row. This is the first row. This is your second row. Okay. This is the first column. This is the first column. And this is your second column. And this is your third column. This is your third column. So how many rows and how many columns are there? 2 rows and how many columns? 2 rows and how many columns? 3 columns are there. So in this case, rows not equal to columns. Number of rows not equal to number of columns. So this type of matrix is known as rectangular matrix. Or you may have 2, 5, 3, 6, 4, 7. This is 2, 5, 3, 6, 4, 7. So how many rows are there? 3 rows and how many columns? 2 columns. So this is known as what? This is also known as a rectangular matrix. So this is one of the types of rectangular matrix. So we will do another type of matrix now. So now, second type of matrix is the square matrix. Square matrix. So in geometry, you know about what is a square, isn't it? A square is that plane figure bounded by 4 sides whose all sides are equal. That means length is equal to breadth, isn't it? Now in this case, what type of matrix is known as square matrix? Suppose if you have A11, A12, A21, A22. Okay? So how many rows are there? First row, second row, 2 rows. First column, second column, 2 columns. So how many rows and columns are there? There are 2 rows and 2 columns. That is, it is 2 cross 2 matrix. That means number of rows is equal to number of columns. If in a matrix, number of rows is equal to number of columns, then that matrix is known as what? Square matrix. Or it may be A11, A12, A13, right? A21, A22, A23. Okay? Then A31, A32, A33. Okay? So how many rows and how many columns are there? This is your first row, second row, third row. There are 3 rows. First column, second column, third column. There are 3 columns. So this is 3 cross 3 matrices. 3 cross 3 matrix. Okay? So number of rows here is 3. Number of columns is also 3. That means number of rows is equal to number of columns. This type of matrix is known as what? Square matrix. So a matrix is said to be a square matrix if number of rows is equal to number of columns, right? So this matrix is known as what? Square matrix. So now number 3 is your row matrix. Row matrix. So what type of matrix is known as row matrix? Suppose you have A is equal to -4, 0, 1, 3. So in a row matrix, there will be only one row. there will be only one row, but the number of columns differs, right? The number of columns may be 4, maybe 3, maybe 2, maybe 1, maybe 5, 6 and so on. But number of rows will be always 1. So if in a matrix, if the number of rows is 1, then that matrix is known as what? Row matrix. Okay? So now number 4 is column matrix. Column matrix. So in case of column matrix, we have A is equal to, this is 1, 2, 3, 4. So in case of column matrix, we will have only one column. We will have only one column, but the number of rows differs. It may be 4 rows, but here it is 4 rows, 1, 2, 3, 4. But only one column is there. That is, number of rows may differ in column matrix, but in case of column matrix, we will have only one column. So number of rows may be 2, it may be 3, it may be 4, it may be 5, 6 and so on, right? But the number of columns should be 1. So if in a matrix, if the number of columns is 1, then that matrix is known as what? That is known as a column matrix. Is that clear now? So next one is, number 5 is your non-matrix. Non-matrix or zero matrix. Non-matrix or zero matrix. So if all the elements of a given matrix are 0, then that is known as non-matrix or zero matrix. Like A is equal to 0, 0, 0, 0. This is known as non-matrix because all the elements here are 0. Or it may be capital B is equal to 0, 0, 0, 0, 0, 0. So if all the elements or members of a given matrix is 0, then that matrix is known as non-matrix or zero matrix. Okay? So next one is number 6. Number 6 is upper triangular matrix. Upper triangular matrix. So what do you know upper triangular matrix? So upper triangular matrix here is a square matrix always. Let us write down. It has 1, 2, 3, 0, 4, 5, then 0, 0, 3. Now this is known as the diagonal. This is known as diagonal of this matrix A, isn't it? 1, 4, 3 is the diagonal. 1, 4, 3 is the diagonal, and above this diagonal there are numbers 2, 3, 5, but all of the elements here are 0. This is known as upper triangular matrix. Okay? So this 1, 4, 3, and if these numbers are 2, 3, 5, but below this diagonal all the numbers are 0 out here. So this is known as what? Upper triangular matrix. Okay? So now 7. Lower triangular matrix. What do you mean by lower triangular matrix? Lower triangular matrix. What do you mean by lower triangular matrix here? Suppose A is equal to, let us write here the diagonal elements as 1, 4, 3, and let us write here 2, 5 and this 6, and all of the elements here are 0. Now this is the diagonal elements 1, 4, 3. You know that this is the leading diagonal. Leading diagonal means in the first column, this is the first column, the first element is 1, then you have to go in this way, right? 1, 4, 3. This is known as leading diagonal. This is also a diagonal. 5, 4, 0 is also a diagonal. In a square there are 2 diagonals, isn't it? This 1, 4, 3 is known as the leading diagonal. That is, in the first column, the first element is 1. If you go in this direction, 1, 4, 3, that is downward, but we are going to the right side. Downward, but we are going to the right side. This is known as what? Leading diagonal. Okay? So below this leading diagonal, if there are some numbers 2, 5, 6, but above this diagonal, if all the elements are 0, then this type of matrix is known as what? Lower triangular matrix. Is it clear now? So now what do you mean by triangular matrix now? Now what do you mean by triangular matrix? Number 8. So now what do you mean by triangular matrix? Triangular matrix is, so I think you know about leading diagonal. Leading diagonal means first column. First element of the first column is 0, then you should take the leading diagonal here, 0, 0, 0. And all other numbers here are non-zeros, that is 5, 6, 7, 8, 9, and this is 10. Now if all the leading diagonals are 0 here, but all other elements are non-zeros, that is, this is 8, 9, 10, 5, 6, 7. This is known as what? This is known as triangular matrix. This is known as what? Triangular matrix. Is that clear to all of you? So this is your triangular matrix. Now number 9 is, let us say, diagonal matrix. Now next is diagonal matrix. Diagonal matrix. Okay. So what type of matrix is known as diagonal? So this is the case of square matrix. In square matrix also you can in square matrix only you can write down the diagonal matrix. So that is 2, 3, 0, 0. So this is known as the leading diagonal from top to bottom here in this direction, that is 2, 3. So these are non-zero elements, but all of the elements are 0 out here. This is known as diagonal matrix of order 2. So why is it order 2? Because there are 2 rows and 2 columns. So this is diagonal matrix of order 2. Or you may have B is equal to, suppose this is 1, 2, 3 and all of the elements are 0 out here. Only the leading diagonal is non-zero, but all of the elements are 0 out here. And this type of matrix is also known as what? Diagonal matrix. Is that clear? As the next one is identity matrix. Number 10 is identity matrix. Identity matrix, or it may be unit matrix. Identity matrix, or also it is known as unit matrix. Okay, it is denoted by what? I. I2 means identity matrix of order 2. So you can get identity matrix or unit matrix in case of square matrix only. If the diagonal matrix, if all the elements in the diagonal matrix is 1, if all the elements in the diagonal matrix are 1, then that matrix is known as identity matrix. That is, I2 means identity matrix of order 2, that means 2 rows and 2 columns, so it is 1, 0, 0, 1, right? 1, 0, 0, 1, that is identity matrix of order 2. So what is meant by I3 now? I3 means identity matrix of order 3, that is 1, 0, 0, 0, 1, 0, and this is 0, 0, 1. So this is known as identity matrix of order 3. So in this case, all the diagonal elements are 1, but all of the elements are 0 out here. So this is identity matrix of order 3. Okay, so this is identity matrix or unit matrix. Is that clear? Now, so now number 12 is equality of two matrices. Equality of two matrices. Equality of two matrices. So let us take the two matrices A and B. The two matrices are said to be equal if they have the same order. So this A is M cross N matrix and this B is also M cross N matrix. So these two matrices A and B are said to be equal if they have got the same order, that is M cross N and M cross N, and they must have the same elements. They must have the same corresponding elements. Is that clear? Suppose if you have A is equal to 2x plus y, 3, 4, and suppose this is y. And B is equal to, suppose this is 3, 3, 4, and y is 5. Right? So now, this A and B are equal. So suppose I say that A and B are equal here. Equal means they must have the same order. This is 2 rows and 2 columns. This is also 2 rows and 2 columns. And all the corresponding elements should be equal. That means the first element here is, the first element of the first row is 2x plus y here. Here the first element of the first row is 3. These two must be equal. That is 2x plus y is equal to 3. This is 3, 3. This is 4, 4. They are equal. And this y should be equal to 5. Okay. So now these two matrices A and B are equal if 2x plus y is equal to 3 and this 3 and 3 are equal, this 4 and 4 are equal, but y should be equal to 5. So y is equal to 5. Okay. So this is your equation number 1. You can put the value for y here. That is 2x plus y is equal to 3, or 2x plus 5 is equal to 3, or what is 2x is equal to minus 2, or x is equal to what? Minus 1. That is x is equal to minus 1 and y is equal to what? It is 5. So x is equal to minus 1, x is equal to minus 1 and y is equal to 5. So if these two matrices A and B are equal, then what are the values of x and y here? The value for x is equal to minus 1 and y is equal to 5. So what is the definition of equality of two matrices? And the two matrices A and B are said to be equal if they are of same order and if their corresponding elements are also same. Is that clear? That is, we can write here capital A is equal to small kij m cross n, and capital B we are generalizing it. That is, matrix A is small a ij. That means ith row and jth column. Ith row and jth column, and this is of order m cross n. This matrix is of order m cross n. And B is equal to what? That is bij, and this is m cross n. Because both these matrices A and B are equal, so they must have the same order and their corresponding elements must be equal. That means Aij is equal to Bij. Is that clear? So these are the equality of two matrices. Is that clear to all of you? So now let us discuss about the symmetric matrix. Okay. Oh, first of all, transpose of a matrix. What do you mean by transpose of a matrix? So next is transpose of a matrix. Transpose of a matrix. Suppose if you have the matrix A is equal to 1, 2, 3, 4, minus 5 and 6. So what do you mean by transpose of the matrix A? That means transpose of the matrix A can be determined by changing rows into columns and columns into rows. Okay? That is, the transpose of the given matrix A can be determined by changing rows into columns and columns into rows. That means, and it is denoted by, transpose of matrix A is denoted by AT or A dash, right? This A, T means transpose of the matrix A, and A dash also means the transpose of the matrix A, right? So now, let us write A transpose. So what do you mean by transpose of the matrix A? You should make this first column as the first row. This now, first column 1, 4 will be here. 1, 4 will be the first row. And this second column will be the second row out here. 2 minus 5, right? And this third column will be the third row out here. That is 3, 6. So this is AT is known as the transpose of the matrix A. Is it clear now? So now this is the transpose of a matrix. I think you have understood it. As the next one is symmetric matrix. Next one is your symmetric matrix. Next one is your symmetric matrix. Okay. So what type of matrix is known as symmetric matrix? कस्तो type of matrix लाई चाहिँ हामी symmetric matrix भनेर भन्छौं भन्दाखेरि let us take an example. Suppose capital A is equal to, let us write it within first bracket, AHG HBF ZFC, right? What is the first row here? AHG. What is the second row here? HBF. And what is the third row here? It is ZFC. Let us transpose this. Let us find out the transpose of the matrix A. That means let us make this first column as the first row. That is AHG, AHG. Next, what is the second column here? HBF. Let us make it the second row here. HBF. And this is your third column. Let us make it third row. GFC. Now in this case, we have converted rows into columns and columns into rows. That is your transpose of A. So, but what do we see here? Both are same, isn't it? AHG, AHG, HBF, HBF, GFC, GFC. But in this case, we have changed rows into columns and columns into rows. But we are getting the same matrix here. And this type of matrix is known as what? Symmetric matrix. So how can you write down symmetric matrix? This is the leading diagonal elements. You can have any elements here, A, B, C, right? A, B, C. But if you write H here, you should write H here. If it is Z, it should be Z. If it is F, it should be F. So that is known as what? Symmetric matrix. So these are the examples of symmetric matrix. A square matrix A is said to be symmetric matrix if A is equal to A transpose. Is that clear to all of you? So second example, I am giving you the second example. Now I am giving you the second example of symmetric matrix. Okay. So A is equal to, let us write down the leading diagonal as 1, 2, 3. Suppose this is 11, this is also 11. Suppose this is 10, this is also 10, right? So this is 9 and this is 9. Let us transpose it. What do we get? So A transpose is equal to, what is A transpose out here? So let us make this first column, that is 1, 11, 10 as the first row. That is 1, 11, 10. Let us make this second column as the second row in this case. 11 to 9, 11 to 9. And let us make this third column here as the third row. That is 10, 9, 3. So this is 10, 9, 3. But check these two matrices. 1, 11, 10, 1, 11, 10. 11 to 9, 11 to 9. 10, 9, 3, 10, 9, 3. But we have transposed it. We have changed rows into columns and columns into rows. But we are getting the same matrix out here. That is AT is equal to A. So this type of matrix is known as what? Symmetric matrix. So what is the definition of symmetric matrix? A square matrix A is said to be a symmetric matrix if A transpose is equal to A. Is that clear to all of you now? So this is the case of symmetric matrix. So now let us discuss about the skew symmetric matrix. Skew symmetric matrix. So now, what is meant by skew symmetric matrix? Okay. So first of all, let us write down the definition here. The square matrix capital A is said to be a skew symmetric matrix. Skew symmetric matrix, comma, if A transpose is equal to minus A, right? The square matrix capital A is said to be a square symmetric matrix if A transpose is equal to minus A. Okay? So now let us take an example out here also. As for example, suppose the square matrix A is given as, suppose the leading diagonals should be 0. All the elements in the leading diagonal should be 0 always, right? Suppose this is H. You should write here minus H. If it is H, you have to write on the opposite side here, minus H. Suppose this is minus Z. You have to write Z out here. Okay? Suppose it is F. You should write here minus F out here. Is that clear? So let us find out the transpose of the matrix A. That is A transpose is equal to. So what is A transpose here? Now you have to make this first column as the first row in A transpose. That is 0, minus H and G, right? Next, this second column becomes the second row out here. H, 0, minus F. And this third column becomes third row out here. That is minus Z, F, 0. Minus Z, F, 0. Okay? So now, I'll tell you about the difference between determinant and matrix now. Okay? So in case of determinant, from only one row or one column, you will take common. Either from the first row, either from the second row, or either from the third row, you can take common. And in case of determinant, columns are also there. So in case of determinant, you should take common either from the first column or from the second column or from the third column. But in case of matrix, you have to take common from all the elements here. That means you have to take common from all these 9 elements here. Okay? Now A transpose is equal to, now let us take minus common from all the elements. Let us take minus common from all these elements, right? So what does it become? If minus sign is taken common here, you don't have to write minus 0 because 0 is neither positive nor negative, so it is 0 only. So minus and minus plus H, you have to change the sign. So you have to change the sign for all the elements here, right? So minus H, then it is 0, then this is F, right? So multiply by minus sign here, it is minus into minus plus Z, it is minus F, then it is 0. Is that clear to all of you? So that means A transpose is equal to what? Minus, actually this is A matrix, isn't it? A, 0 H minus Z, minus H 0 F, Z minus F 0. So this is minus A. Is that clear? So if A transpose is equal to minus A, then what is the definition? What do you call this A as? This A is a skew symmetric matrix. So I think you have understood it. So how can you write down the skew symmetric matrix example? 0, 0, 0, leading diagonal should be 0. If it is H, you should write here opposite sign minus H. If it is minus Z, you should write here plus Z. If it is F, you should write here minus F. So this is your skew symmetric matrix. Is that clear to all of you? So now, the next part is how can you convert a given matrix into sum of skew symmetric matrix and symmetric matrix. Now, there is a method. So how can you convert a given matrix as a summation of symmetric matrix and skew symmetric matrix? Okay? So now suppose a matrix A is given. A matrix A is given. You have to convert it into summation of symmetric matrix and skew symmetric matrix. Okay? So you write here first A plus A transpose, but this is only A here, right? Plus A minus A transpose, right? But A transpose gets cancels. You are getting A plus A as 2A, but there is only one A here. So what will you write here? This is half and this is half. So if you multiply this A plus A transpose by half and A minus A transpose by half, and if you simplify it, you will get A only. That means this half into A plus A transpose will be the symmetric matrix. So automatically this will be the symmetric matrix. Okay, and this second term will be the skew symmetric matrix. This second term is the skew symmetric matrix. This second term is the skew symmetric matrix. Okay, so I think you have understood it. So today we have discussed about the different types of matrices. So in the introduction part, we discussed about the representation of a matrix. So how can we define a matrix? Then today we did the types of matrices. Okay, so in the next class we will do more problems on matrices. Okay, so this much is for today.